Hey everyone! So in this video, I like to continue our discussion of different identities, and in particular, I like to talk about the product to sum identities. And so I should say that the main value in covering all of these different identities is that they give us a way of manipulating trigonometric expressions. And sometimes we might encounter an expression that might not be the easiest to work with, and depending on what we're trying to do, we might want to manipulate it into a slightly friendlier one. And friendly might mean something different based on what kind of context we're in. Anyways, one sort of manipulation that may be beneficial for us is to be able to convert products of sine and cosine into sums of sine and cosine. And so that's exactly what these product to sum identities are. And so I've listed them out here. And I should also say that these aren't the most common identities that appear in, say, calculus classes. And so, they might appear here and there, but they don't appear all that frequently. And so I definitely would not encourage you to memorize these identities. I don't have these identities memorized, but you should know that they exist, and you should know how to use them, and you should also know where they come from. And so let's start with this idea of where they come from. So these identities, they come from the angle sum and angle difference identities. We can kind of see on the right sides of these identities that they involve angle sums and differences. And so here, maybe let's begin our discussion of these identities by proving one of these identities. So let's try and prove this identity in the middle, the identity involving sine of u times sine of v. So like I said a moment ago, these identities can be proved using the angle sum and the angle difference identities for sine and cosine. And in particular, this identity involves an angle sum and angle difference of cosine. And so let's start by identifying or reminding ourselves what the angle sum and difference identities for cosine look like. So here, remember that cosine of the sum of two angles, let's say u and v, well, this is equal to cosine of u times cosine of v, take away sine of u times sine of v. And the cosine difference formula, cosine of u minus v, well, this is almost the same equation, but instead of the sum of these two terms, we get the difference of these two terms. So we have cosine of u times cosine of v. Instead of the difference of these two terms, we have the sum of these two terms. So cosine of u times cosine of v plus sine of u times sine of v. And so we want to combine these two equations in some way so that we end up with just sine of u times sine of v on one side, and then on the other side we have an expression involving cosine of u plus v and cosine of u minus v. And so the first thing I notice is that in our identity here, the one we're trying to show, we have the difference of cosine of u minus v, take away cosine of u plus v. So maybe let me take this first identity that we have here and multiply throughout this entire equation by a negative sign. Right? In our identity we're trying to prove there's a negative cosine of u plus v. Let me contribute a negative sign across this entire first identity here. So if I negate the left side, that's the same as negating the right side. So here, if I negate the right side, that's negating cosine of u times cosine of v. And then negating negative sine of u times sine of v makes this a plus sine of u sine of v. And now another thing I can do is I can add these two equations together. Right? If the left side always equals the right side for both of these identities, if I add these two identities together, the left sides with the left sides, the right sides with the right sides, well, they'll still both be equal. And so let's do that. If I add these two left sides, then we get cosine of u minus v. And then added with negative cosine of u plus v gives us minus cosine of u plus v. And then adding the right sides of our equations together, well, here, negative cosine of u, cosine of v, added with cosine of u, cosine of v, well, those would cancel out. And then we're going to add the sine of u, sine of v, together with itself, sine of u, sine of v. So this gives us two sets of that value, right? 2 times sine of u times sine of v. And so we're trying to show what sine of u times sine of v is equal to, right, to prove our identity highlighted in purple. And so we want to get sine of u times sine of v alone. We can do that by dividing both sides by 2. So maybe let me use a different color again. And so on the right side, we get sine of u times sine of v. And then on the left side, well, we have our cosine of u minus v. Take away cosine of u plus v. And this is all divided by 2, which is the same as multiplying this expression by 1/2. So I'm going to write a 1/2 in front of this and just put parentheses around our entire left side. So here we've shown that sine of u times sine of v is the same as 1/2 cosine of u minus v, take away cosine of u plus v. And that's exactly the identity we wanted to show. So let's get some practice using these identities. Here I've got the expression cosine of x times sine of 4x, and I'd like to rewrite this as a sum. And so here I've got the identity involving a product of sine and cosine. And so here this is an identity we can use to accomplish our task here. But one thing I like to notice is that u in our identity, it represents the input angle to our sine function. And so here, this 4x, this is our angle u, and this x is our angle v. And so maybe to make this expression better align with our identity, let me just rearrange it a little bit, right? So, the order in which we multiply two quantities doesn't matter. And so let me rewrite it so that this expression has sine in front, so it matches our identity better. I'm going to write this as sine of 4x times cosine of x. And so our identity tells us that this is 1/2 times sine of 4x plus x plus sine of 4x minus x. And so here we can rewrite this as 1/2. This is sine of, 4x plus x, that's 5x. And then sine of 4x minus x, well, that's 3x, sine of 3x. And another thing we can do is we can distribute that 1/2 multiplication. This comes out as 1/2 sine of 5x plus 1/2 sine of 3x. And so one thing I should say is that if we weren't careful and we just quickly labeled this x input value of cosine, if we thought of that as our angle u and 4x as our angle v, then we would get negative, we would end up here with negative 3x, right? We'd end up with x minus 4x, which would give us negative 3x. And sine of 3x is not the same as sine of negative 3x. And so we'd end up with an incorrect expression at the end of the day. So let's go through the same motions, but for the expression 3 times cosine of 4x times cosine of 7x. And so there aren't any parentheses in this expression here, but it's safe to assume that this 4x represents the input of our first cosine function, and this 7x represents the input of our second cosine function. And so here, 4x we can think of as our first input value, we can think of as u, and 7x we can think of as v. And we can do this safely because here, the expression and the identity, they both just involve cosine of some angle times cosine of another angle, and it doesn't really matter what order we have these in. It's not really going to change the result of rewriting our expression. And so let's do this. Let's rewrite this. So we have 3 times cosine of 4x times cosine of 7x. And so we have an identity for this cosine of 4x times cosine of 7x. So let's rewrite this so that we have 3 multiplied with the result of rewriting our cosine product. Right, so this is 1/2 times cosine, maybe I'll put parentheses here, cosine of, our first angle added with our second angle, so this is 4x plus 7x, summed with cosine of our first angle, take away our second angle, 4x minus 7x. And so we can simplify our expression in purple. This is 3 times 1/2 times cosine of 11x plus cosine of negative 3x. Do I have all the parentheses here? So I think I need one more. And we can distribute. Actually, let's multiply this 3 in with 1/2, so this becomes 3/2 times cosine of 11x plus cosine of, cosine of negative 3x, that's actually the same as cosine of 3x. Cosine is an even function, and this means that cosine of an angle is really the same as cosine of negative that angle. Cosine doesn't read negative input values as different. And so that 3x input to our cosine function, we can rewrite it as negative 3x to make that just a little bit simpler. And the last thing we can do here is we can distribute that 3/2 to get cosine, or 3/2 cosine of 11x plus 3/2 cosine of 3x. And so one thing I'd just like to reiterate is that it didn't matter if we called u 4x or u 7x in this case, because the only difference that would give us would be whether or not we got a negative 3x here or a positive 3x here. And those are the same for our cosine function.